Okay, the first problem is about adverse selection and about car insurance. You're familiar with this concept from the Micro2, yes, about car insurance. Okay, what we have? The risk neutral firm provides car insurance. Let's write down. Then, a typical contract consists of a fee beta and a reimbursement amount alpha paid on top of beta. Contract for insurance consists of beta, it's a fee that you pay for this insurance, and then alpha, it's reimbursement amount that is paid when you broke your car, when here is the car incident. And what our firm should do, it should pay back to you the fee plus this reimbursement amount. So this reimbursement amount on top of beta. Okay. Where alpha is transferred only in the case of an accident. There are bad and good drivers who own identical cars of the value of 100. So we have two types of drivers. Bad drivers and good drivers. Each of them has the car that they value at 100. The proportion of type bad individuals is 1/2. Proportion in the population. 1/2 of bad drivers, 1/2 of good drivers. Then, bad drivers commit an accident with probability 1/2, and good drivers commit an accident with probability 1/4. Here is probability of accident. Bad drivers, probability 1/2, P bad, and P good is 1/4. So good drivers drive better. Then, in which case they lose their car. So loss is equal to 100. If here is an accident. For each type I, the firm's objective function takes the following form. For the firm, the profit from each type is equal to, in any case, they should pay to our firm beta minus, with probability of an accident of each type, we should pay back, as a firm, we should pay back beta plus this reimbursement amount. So here is the profit from each type of driver if they buy the insurance. And we can rewrite 1 minus pi beta I minus pi alpha I for each type. For I equals to bad, good. Then, the drivers have identical preferences over wealth. So they are, if we have such utility function, yes, they have what preferences for risk? They are risk averse, yes. So our first task, our baseline. Suppose the firm can perfectly observe the driver's type and has all the bargaining power and derive a first best contract. So the firm perfectly observe driver's type and has all the bargaining power such that our firm can extract all the surplus from our drivers. All bargaining power And we should find first best contract. It is a contract in case of symmetric information, when we have all information from both sides. So, what our firm will do? If our firm knows the type of the driver, so the driver came and we perfectly observe its type. So, if it is a bad driver, we will give him one contract. If it is a bad type, another contract. So 2 contracts for each type, their contract. Yes. So let's write down it. We should do different contracts. For each type, beta I, alpha I. Then how we will derive these contracts? We should, as a firm, we should maximize profit with a constraint for our driver of each type. So we should maximize by choosing alpha I, beta I, our profit from each type, 1 minus pi, beta I, minus pi, alpha I. Subject to constraints. Alpha should be greater or equal than 0, and beta can belong, this is a fee, belong from 0 to the maximal amount that they can pay. They own a car that they value at 100, so up to 100. And we should write down the individual rationality constraint that you know it from the lecture. What means individual rationality constraint? The utility of driver from buying the insurance should be greater or equal to the situation, to the expected utility of our driver when he doesn't buy the insurance. So let's write down. So it should be beneficial for our driver to buy the insurance. So expected utility of driver I, if he buys the insurance, is equal to, with probability pi, no, with probability 1 minus pi, there is no accident, and the utility will be from what? He has his car, no accident, but he paid this fee, beta I, plus with probability pi, here is an accident, and what we have? He had the car, paid for insurance, lose the car, loss. This is wealth, this is loss. And here is the accident. So our firm pays back beta plus reimbursement amount alpha. And this expected utility, if I buy the car insurance, should be greater or equal to expected utility of each type when they not buy insurance. And it is equal to, with probability pi. There is no accident and we have the car, with probability 1 minus pi. We had the car, but lose all of this. So this is the profit maximization program subject to individual rationality constraint for each type. Individual rationality constraint, IR. How we should solve it? First of all, we should understand something about our constraint. So we should say that, for example, suppose individual rationality constraint holds with inequality, but then say it is not optimal. Why? Because we can increase, for example, fee and increase profit such that we have all bargaining power, such that we will extract all the surplus. So here will be equality. Let's write down it. Firm with all bargaining power extracts all the surplus from each type of driver. So individual rationality for each type binds, holds with equality. Okay, and then how we should solve it? How to solve mathematically such maximization program? What you can tell me? How to solve?
Maybe using Lagrange?
Yes, we will use Lagrange, exactly. I will write down Lagrange maximization once, and then I will do it faster. So we write down Lagrange function depending on beta I, alpha I, and Lagrange multiplier. It should be the profit 1 minus pi beta I minus pi alpha I plus Lagrange multiplier multiplied by the constraint, and everything from right to left. 1 minus pi square root out of 100 minus beta I plus pi square root out of alpha I minus pi square root out of 100. This we should maximize by beta, alpha, and Lagrange multiplier. We need first order condition, the L, the beta I, and the L, the alpha I. The beta equals to 1 minus pi here, minus alpha multiplied by 1 minus pi divided by 2 square root out of 100 minus beta I equals to 0. By alpha I minus pi plus alpha pi divided by 2 square root out of alpha I equals to 0. This is the first order condition, and we can see that they are similar, but they are different only in 100 minus beta and alpha I. So for this system in optimum, 100 minus beta I should be equal to alpha I. You see this? Same. We should solve it and to find this. So this should be in optimum. And as always, we have now one equation with two unknowns. We have one equation now with two unknowns. We should put this optimal condition into our constraint. Here we have constraint individual rationality. Let's put it. 1 minus pi square root out of alpha I plus pi square root out of alpha I should be equal to pi square root out of 100. From here, we will express that alpha I star is equal to how much? Or I have a mistake. We have our car here in individual rationality with probability 1 minus pi, and here pi. Rewrite, please. And here also 1 minus pi. Yes, this is the probability that we do not have accident. So here will be 1 minus pi, root out of 100. So alpha I will be equal to 1 minus pi square multiplied by 100. And put this into beta, into optimal condition. Beta I is equal to 100 minus alpha I star, and it is equal to, I will tell you, 100 multiplied by pi multiplied by 2 minus pi. So this is the first best contract, but it's not the answer yet, because we should check that alpha is exactly greater than 0. Let's see, square multiplied by 100. Yes, it's exactly greater than 0. Okay. Then beta should belong from 0 to 100. If you will put probabilities for each type, 1/2 and 1/4, you will see that beta is exactly belongs from 0 to 100. And our next step is to check, is it profitable for our firm to provide such a contract for each type? How we can check it? We should compare the profit if our firm provides this insurance with profit 0 if she does not provide the insurance. So profit of firm I, if she provides the insurance, will be put this into profit, these optimal numbers into profit, and this will be 1 minus pi multiplied by beta I star minus pi alpha I star, and this is 100 pi multiplied by 1 minus pi. And you see that this is 100 multiplied by probability multiplied by probability. It is exactly greater than 0. So it is optimal to provide car insurance for each type. For each type. So firm provides insurance to both types of drivers. And our first best contract is here. This is first best contract. Guys, please questions. I will erase right now.
From which we take beta I star 100 minus A
Alpha, here,
one.
from optimal condition. You see? Beta is equal to 100 minus alpha in optimum.
Yes, but where is 100 minus 100, 1 minus pi squared?
This one, okay.
You open the brackets and solve.
Yeah.
Okay,
I wrote down the answer.
Okay.
I wrote down the answer to compare faster, yes, to make conclusions. So next, second point. Now, in our main point in this task, our firm can no longer recognize this driver's type. So we are now in the station of asymmetric information, when we have only driver. We don't know it's bad or good. We know only the probability, the proportion of bad and good drivers, yes, in our economy. So in such situation, when we have only driver, we will have one contract for all types, one contract. And we should find second best pooling contract. for driver, not for the type, but for all drivers. How do you think, who will be better off in case of asymmetric information?
Bad drivers.
Bad drivers, yes, because they know that there are good drivers also, so they will pay lower fee, and yes, they will be only bad drivers will be better off. In this situation, they will have the surplus, but let's check it. So now what we should maximize? By choosing this pooling contract, alpha and beta, we should maximize not the profit, but expected profit. We know that with probability 1/2, the proportion of bad drivers, we will have profit 1 minus p bet multiplied by beta minus p bet multiplied by alpha, plus with proportion 1/2 probability to sell the contract to good driver, we will have profit 1 minus p good beta minus p good alpha. So this is our expected profit from selling the contract to driver. We don't know the type, subject to constraints. But here we have two constraints, such that good driver will want to buy the insurance, and bad driver also should want to buy the insurance. So we will write down two individual rationality constraints for bad and for good driver. First, our technical constraints alpha greater or equal than 0 and beta belongs from 0 to 100. Then, now individual rationality for good driver. With probability 1 minus p good, I will have 100 minus beta, plus with probability p good, I will have square root out of alpha. And this should be greater or equal than, with probability 1 minus p good, I will have my car. Individual rationality for bad driver. Same, but with different probabilities. 1 minus p bad, square root out of 100 minus beta, plus p bad, square root out of alpha. And this should be greater or equal than 1 minus p bad, square root out of 100. So this is our maximization problem. Our first step, we should understand what conditions should hold with equality, should bind, and what should not bind. Yes, but intuitively we understand what will be the answer. But you told me that only bad drivers will be better off. So if bad drivers will be better off in case of asymmetric information, they will have surplus. Yes, so for bad drivers here should be strict inequality, and for good drivers here should be equality, no surplus for our good drivers. Yes, but we should prove it. So we should consider all four situations and then came to conclusion, strict proof. Let's start. I will show you once. In the next problem, I will not show you, but you should do the same in the next problem also. So, what will be with individual rationality constraints in optimum? Consider all four situations. Situation A, IR for bad and IR for good, not bind, both with strict inequalities. It's not optimal. Why? Because we can increase fee to improve our profit, and that's all. Let's write down firm can deviate and make exactly one IR binding to increase the profit. So this is not optimal case. B, when individual rationality for both binding if here is equality, here is equality, let's express, for example, from IR good, something put into IR bad, and we will see contradiction. From, for example, IR bad, we have, let's put our probabilities. 1/2 square root out of 100 minus beta plus 1/2 square root out of alpha is equal to 1/2 square root out of 100. From here, express, for example, 100 minus beta. It is equal to how much? 100 square root out of 100 minus alpha. Minus square root of alpha. And put this into IR good. In IR good, probabilities 3/4 square root out of put this 100 minus square root out of alpha plus 1/4 square root out of alpha, and this is equal to 3/4 square root out of 100. From here, express alpha. We will have minus 1/2 square root out of alpha equals to 0. And that's why alpha should be equal to 0. And beta, from here, alpha equals to 0, beta should be also equal to 0. But with such contract, our profit is 0, yes? But we can improve such profit. We can have positive profit, so it's not. It is also not optimal for us. Can be improved. So it's also not optimal case. Case C, when IR bad binding, IR good not binding. Same steps as in point B. We express from IR bad because it holds with equality. Square root out of 100 minus beta equals to 100 minus square root out of alpha, and put it into individual rationality for good type. And when we will put it, we will see that minus 1/2 square root out of alpha should be greater than 0. But we came to a contradiction. Yes, here is with minus and should be greater than 0. Contradiction. So it's not optimal. And we consider 3 cases. So the 4th case is optimal. So in optimum, IR good should bind, IR bad not bind. And then we can write down our Lagrange and solve. So Lagrange now will be when we have only one constraint with equality. So we will put only this one constraint with equality into Lagrange. IR bad here equality. Lagrange depend on alpha, beta, and lambda equals to expected profit 1/2 multiplied by 1/2 beta minus 1/2 alpha plus 1/2 3/4 beta minus 1/4 alpha plus Lagrange multiplier and our individual rationality only for good driver. And you see that we extract all the surplus only from good driver, and bad driver is better off compared to the previous case because he has, in optimum, he has his own surplus, positive surplus. Here we will write down 3/4 square root out of 100 minus beta plus 1/4 square root out of alpha minus 3/4 square root out of 100. And this Lagrange we should maximize first to the condition, blah, blah, blah. So system refers to the condition. From here, we will have optimal condition that we should put into the rationality for good. And from here, we will have this contract. Contract will be beta is equal to 100, 1 minus 27 divided by 32 square. And alpha will be 100 multiplied by 15 divided by 32 square. And if we will compare it, with the previous, bad drivers, this is second best pooling contract. And from this citation, we know that only bad drivers are better off. Let's write down it. Only bad drivers benefit from asymmetric info. They pay lower fees. And obtain a positive surplus. Why are bad or does not benefit? Good drivers get the same surplus as before. Also, you can compare profit of the firm, and you will see that our firm is also worse off. This from first best, this from second best. If you will put all numbers, you can compare, and you will see that the firm loses her profit. In its expected profit. Because there is no way to extract all the surplus from both drivers in case of asymmetric info. Expected profit is, there is no way to extract all surplus from both types. In case of asymmetric info. That's all for the problem 1. Please ask. So situation is easy. Yes, as in previous in the previous class, we had also the problem of adverse selection, and here we also told that only bad type is better off in case of asymmetric info. Yes, and that's all. So, okay, it's clear, guys. Please.
Yes.
Okay. Next problem. Here is the topic is moral hazard in the workplace. Let's read. In this problem, we should understand the task. It's the main. But let's read. A risk-neutral firm hires a risk-averse worker to run a project. So we have risk-neutral firm. Hires a risk-averse worker to run a project. What we have? A successful project generates the output 12 for the firm. If the project is successful, we will have the output 12. The firm will have output 12. Otherwise, the firm enjoys only 5. If it is not so successful, yes, for example, it's not fail, but not success. We'll have low output, 5. To perform the task, the worker can exert effort, 1 or 0, high effort or low effort. Worker's effort. High effort equals to 1 or no effort equals to 0. But if you exert the effort, it's costly for you, yes? So we have costs equals to E. So the function of costs for worker to exert effort. So the main. If he chooses high effort, the project succeeds with probability 0.9. So if we exert high effort, so the project will be successful with a probability 0.9. That means that not all depends on the worker, yes? Probability of success (0.9), and if our worker exerts a low effort, the project succeeds with probability 0.1. Probability of success, if I do not do anything, is 0.1. So here is the probability that if worker does not do anything at work, the project will be successful anyway. Yes, but the probability is lower. This is the main. Then the worker's preferences over wage are characterized with square root out of wage. And this is, we see that he's risk averse, yes? And the utility equals to 2 shapes his outside option. What that means? That means that our worker can work not only in this firm, but in other firms. And if he will choose to work in other firms, he will have the utility 2. Okay? So he will work in our firm only if the expected utility will be higher than 2. It's like reservation wage, but here reservation utility. First point, as always, perfect information. Assume that firm can perfectly observe the action taken by the worker. We should find the first best contract. What we will do? Our firm will maximize her profit subject to individual rationality constraint as before. But here in this task, what is the problem? Our profit depends on the efforts of our worker. So if he exert efforts, we will have the probability of high output higher, yes? But if we want our worker to exert efforts, it's logical that we should pay him more, yes? But the wage for worker is the cost for the firm. So, and we should compare the situations. Maybe it's more profitable for us not to ask our worker to exert efforts, because we have the probability that project will be successful. But if he does not do anything, we will pay him low wage, lower costs, and we then should compare profits in 2 situations. So we consider 2 situations. First situation, suppose we want our worker to exert efforts, high effort. So in such situation, we perfectly observe his effort. We see that he exerts this effort. What will be our profit? What we will maximize? We maximize our profit depending on wage in case of success and in case of not success of our project. We should write down the note about it. Let's write down the note. Wages wage the firm pays when high output or low output realizes. Okay, so what will maximize? If we ask our worker to exert high efforts, we will have high output with probability 0.9. Output 12 minus the wage if project is successful, plus 0.1, we will have low output 5, and we will pay low wage. Subject to individual rationality constraint. Yes? The expected utility from working in our firm should be higher or equal to the outside option utility. So with probability 0.9, our worker will have high wage. Plus with probability 0.1, our worker will have low wage. minus costs. If he exerts effort, costs are equal to 1. This is costs from EH. And this expected utility from working in our firm should be greater or equal than outside option 2. This is individual rationality. First, we should prove that individual rationality will hold with equality. How? If we'll decrease wage, we will increase our profit, and that's all. Yes? Let's write down binds. IR binds an optimum. Otherwise, profitable deviation. Then you write down the Lagrange, depending on VH, VL, and Lagrange multiplier. Then Fox. From this Lagrange. We can write once. Okay, let's write down. Minus 0.9, because it's easier, plus 0.9 lambda divided by 2 square root out of VH. Here, minus 0.1 plus 0.1 lambda 2 square root out of VL equals to 0 equals to 0. And you see, the same as in previous task, VH should be equal to VL in optimum. What is the conclusion? That in optimum, the wage of our worker will not depend on the success of the project. Yes. In any case, our worker will have the same wage. Project is successful or not, same wage. Yes. So this we will call full insurance. Put this optimal condition into our constraint, individual rationality, and you will see that, okay, 0.9 square root out of VH plus 0.1 square root out of VH equals to 3. Yes, and from here we will see that VH is equal to VL equals to 9. So such wage we should pay to our worker in any case if we want from him high effort. What will be the profit in this situation if we want high effort? Put these wages into our profit, 0.9 multiplied by 12 minus 9 plus 0.1 multiplied by 5 minus 9. Expected wage. It is equal to 2.3 if we will calculate. So here, please, questions I will raise. Next situation. What if we want from our worker to exert low efforts? Suppose low efforts are optimal for our firm. What change we will have in our profit? In probability of success, yes? So the profit of our firm will be right now, we'll maximize by choosing wages. The probability of success will be 0.1 if here are low efforts. And we will have 12 minus wage plus 0.9, 5 minus wage if no success. Subject to individual rationality constraint, individual rationality with probability 0.1. I will have wage from successful project plus with probability 0.9, I will have wage from not successful project, but I should not pay costs for efforts, minus 0. This is cost from low efforts. And this should be greater or equal than outside option 2. Then we will prove that IR binds, then Lagrange, then answer. Okay, same steps. IR binds, full insurance in optimum, put this into IR, and we will have wages equal and equals to 4. So let's count the profit. If we want from our worker low efforts, it will be equal to 0.1, 12 minus 4. If we need from our worker on the low efforts, we can pay him less. Yes, we can lower the costs. Plus 0.9, 5 minus 4. And this, if we will count, 0.8 plus 0.9, 1.7. Then we compare our profits in two different situations. We see that it is optimal for us to ask for high efforts. So let's write down it. That's why optimal efforts are equal to 1, and first best contract is 9. This is first best contract. In any situation, in any case, to pay 9. Please, questions? So, what are your steps? You should consider high efforts, what profit will be, low efforts, what profit will be, then compare profits, and then write down the answer about first best. Because here can be the situation that profits will be reverted. Yes, that from low efforts, profit will be higher. If profit is higher from low efforts, so our answer will be optimal optimal efforts equals to 0, wage is equal to 4. So, okay, clear, please.
Yes.
I erase. Now we continue. Second point, asymmetric information. In asymmetric information, we cannot see efforts of worker, but we can we see only the output. Yes, only the output, high or success or not success. So, and for making the contract, we should make the worker to exert such efforts that we want. But the only key how to make the worker to exert such efforts is by the contract, is by wages. So now, for example, if we want from our worker to exert high efforts, we should have wages different in two situations. For example, we will say that, okay, we will pay you more if project will be successful, and we will pay you less if the project is not successful. So here are the incentives for worker to exert efforts to increase the probability of success and to have higher wage. This is the main point. So let's write down. Point 2. Only output is contractable. Then firm cannot see the worker efforts. Only output. And we should find second best contract. So the best contract in case of asymmetric information. If first best contract is not affordable for us. So when efforts becomes unobservable, the firm must provide sufficient incentives to induce the action it is willing to implement. Yes? Firm should provide sufficient incentives to induce the action it is willing to implement. And then we should consider two situations, when we want high efforts or when we want low efforts. When we want high efforts, suppose high efforts is optimal for us. What will be in our maximization problem? Profit, we should maximize by choosing two wages. If high efforts are optimal, the probability of success is equal to 0.9. So with probability 0.9, we will have high output minus this wage in case of success, plus 0.1 low output minus the wage in case of not success. Subject to individual rationality as always. With probability 0.1, I will have high wage. With probability 0.1, I will have wage in case of not success. I will exert effort -1, and this should be greater or equal than 2. My outside option. This is IR as in previous case, but we will have second constraint for our worker. He should want to exert high efforts. It should be beneficial for him. So this is the expected utility if I exert high effort. 0.9. And this expected utility, if I exert high effort, should be greater or equal to the expected utility if I will exert low effort. Low effort, if I will exert, I will have high wage with probability 0.1 plus with probability 0.9, I will have low wage, but I should not pay the cost for effort. And this constraint we call incentives compatibility constraint here. We should provide sufficient incentives, and this is incentives compatibility constraint for our worker. So here we should solve this maximization problem for our firm. Our steps as in previous task when we had two constraints. When we had two constraints, we should consider all four situations, not binding, both this binding, this not binding, this not binding, this binding, and both binding. We should consider four cases, and then came to conclusion what will be the optimal case. Let's write down first. So, 4 cases about IR. IC. A, not binding, both not binding. But this is not optimal because we can decrease wages and make at least one constraint binding. Not optimal. B, IR binding. I see not. Also not optimal, we can change wages and increase our profit. C, IR binding, not binding. I see binding, also not the case, same conclusion as in B, and that's why in optimum, both constraints binding. Here equality, here equality. So your steps are the same as in previous tasks, so I will not write it one more time. So, okay, IR 0.9 square root out of VH plus 0.1 square root out of VL equals to 3. And from here, 0.8 square root out of VH minus 0.8 square root out of VL equals to 1. This is IC. We should solve this system to equations to unknowns. From here, we will have when success wage will be, I will tell you the answer, 625 divided by 44 or 64. And if not success, 225 divided by 64. And if we will compare these two wages with the case of symmetric information, we will see that wage in case of success is higher than 9, and wage in case of not success is lower than 9. So now there is no full insurance for our workers. So the worker shares the risk now with the firm. Yes? Let's write down it. Now, worker shares the risk with the firm. And becomes a residual claimant. A residual claimant, that means that worker shares the risk with the firm. Yes, he will say that if I will exert effort, the probability of success will be higher, so I will have higher wage. And if in case of not success, I will have lower wage. So I want to exert effort. Here are incentives. What means residual claimant? По-русски остаточный истец, и все. Ну, то есть это то же самое, да, что работник, да, разделяет риск с фирмой, да, то есть работник тоже беспокоится о том, будет проект успешен или нет. В предыдущем пункте он не беспокоился, потому что мы платили одинаковую зарплату. Окей. Let's count the profit if we want high effort from our worker, and this will be put these wages into a profit, and this will be 2.16. Next. What if it's too costly for us to pay such wages? And this is the case when we do not want from our worker high efforts if there are low efforts, if we want low efforts. Suppose we want low efforts. What that means? We should maximize our profit. If here are low efforts from our worker, the probability of success is 0.1. We'll have 12 minus wage in case of success. Plus, with probability 0.9, we will have output 5 minus wage in case of not success. We maximize by VH by L, greater or equal than 0. Subject to Our workers should want to work in our firm. So this is individual rationality. 0.1 square root out of VH plus 0.9 square root out of VL minus 0 greater or equal than 2. Same as in point 1. But we do not need here incentives compatibility. Yes, because we do not need to make our worker not to exert efforts, because efforts are costly. And if we want our worker not to do anything, so he will not do anything. He will not change the decision. So let's write down this, the maximization program like this. Let's write down this conclusion. No need to specify incentives compatibility as agent will never deviate and exert costly effort. Instead of effort equals to 0. And that's all. So, but this problem, this maximization problem, we solved in the point 1. So from here, we will have VH equals to VL equals to how much? 4, yes, or 5? 4. This from point 1. And the profit, if we want low efforts, equals to 1.7 from point 1. Compare these two profits, and make the conclusion. What will be the second best contract? So, profit, if we want high efforts, in case of asymmetric information, is higher than profit with low efforts. Here, 2.16, 1.7. So, second best contract requires high effort, and wages in case of success and not success will be different. This is second best contract in case of asymmetric information. And what conclusion we can make? We can say that firm will lose her profit compared to perfect information. You see, that's here 2.16, and in perfect information we had 2.3. Let's write down profit in case of symmetric. Okay, first best. Profit from first best, 2.3, higher than profit from second best, 2.16. Why? Because as a result of an observable effort. Yes, an observable effort. Why? Because now we need to pay more to our worker to make him to want to exert high effort. Where to write it? I will write here. Last conclusion. One more time. Profit of our firm decreases as a result of an observable effort. Now it needs to pay the worker more to provide sufficient incentives to exert high effort. From my side, that's all. Please, guys, ask questions. If you don't have questions, see you next Tuesday, our last class about externalities. We have time to answer. I have time to answer your questions now, please.
To provide sufficient and
sufficient incentives.
Okay.
One more time, I will send you how to write these problems from previous class and from this class on Friday at the end of the week. What else? I don't know. Guys, do you have questions?